Hi guys, and welcome to PyMath. In today's video, we'll be covering some basic trigonometric identities. So I've already written down what you need to know coming into this video. So obviously, this is a right triangle, and this is theta. This is the angle we're going to be looking at today. So relative to theta, this is the adjacent side, this is the opposite side, and this is the hypotenuse. And I've also labeled some basic trigonometric ratios. So sine theta is always opposite side over hypotenuse. And similarly, cos is always adjacent side over hypotenuse. And tan is always opposite side over adjacent side. And these three ratios are just the inverse ratios. So sine and cosecant are inverse. Cos and secant are inverse. And tan and cot are inverse. So the trigonometric identities we're going to be proving today are sine squared theta plus cos squared theta equals 1. So that's the first one we're going to be doing today. So we know that sine theta is O over H. So we can just write O over H whole squared because it's sine squared theta. And similarly, we know that cos theta is A over H. So we can just write down plus A over H. And that's also whole squared. And that's 1. Now if we simplify this, we get O squared plus A squared over H squared. And now you might be wondering, what do we do from here? How do we prove that this is 1? I think some of you might have noticed that I've written this down over here, which is basically just Pythagorean theorem, which we've been taught from grade 3. So it states that opposite side plus adjacent side, both of them whole squared, is equal to the length of hypotenuse. So we have this over here. So opposite side plus adjacent side. We know from Pythagorean theorem that this equals this. So instead of saying opposite side plus adjacent side, we can just write hypotenuse squared over hypotenuse squared. And this, of course, equals 1. So there are 2 more trigonometric identities to go. The second one being secant squared theta minus tan squared theta is equal to 1. I'll just write that down quickly. So to prove this, we also need to use these ratios. So we know that secant theta is this, hypotenuse over the adjacent side. So we can write it down as hypotenuse over adjacent whole squared minus tan squared theta, which we know is opposite over adjacent. So we can write that down as opposite over adjacent whole squared. And this also equals 1. So if we simplify this, we get H squared minus O squared equals A squared. And like we did last time, we're just going to use Pythagorean theorem to figure this out. So what we will do is we can rearrange this to say that A squared equals H squared minus O squared. We can rearrange that to, after rearranging it, you'll notice that this is the same as this. So a squared minus o squared is equal to a squared. So if we just write that down, we get a squared over a squared, which is obviously, again, 1. So we have one more trigonometric ratio to go, and that is cosecant squared minus cot squared is 1. Let me just write that down. So what we can do is we can write cosecant like it's written here. Hypotenuse over the opposite side. So that is whole squared. So and then we subtract from that cot squared. We know that cot is adjacent over opposite. So we can just subtract from that adjacent from over opposite whole squared. And we can simplify that to hypotenuse squared minus adjacent squared over opposite squared. And like we did last time, if we just simplify this, we can get o squared equals h squared minus a squared. So you'll notice again that this is the same as this. So we can just write this is equal to o squared over o squared, which is 1. And thus that proves this identity. I hope you enjoyed this video. If you did, please like, share, and subscribe because it really helps the channel out a lot, and thanks for watching.